All right, we're looking at page 94 in our packet. We are talking about spheres, pyramids, and cones. So on the front, we have all pyramids, and the volume of a pyramid is 1/3 the base of the figure times the height of the figure. Now, when I talk about the capital B, that's the base. So if this is a square or a rectangle or a triangle, that's the area I'm looking for. And the height, that is the 90-degree drop, that altitude. So I don't want a slant height. All right, so if you look at number 2, what type of pyramid is that?
Square.
Yeah, I'm going to go with number 2. That's triangular pyramid, right? So what's the base? Triangle. And then I need to find the area of the base. So it's 1/3 the area of the base. And I have the height of the figure from the tip of the pyramid down to the base with 90 degrees. The height of it is 10. But what's the area of the base?
The base times the height of the triangle.
Yeah, so you're pretty much ignoring all this. And you're looking at this outline of your triangle. A little abstract, so we're trying to make it a little easier. And you have to look for that 90-degree angle. So here is my base, which is 6, and my height of the triangle is 8. So you don't have to do this, but if you spin it around, I'm talking about this being the base of my triangle and that being the height of my triangle. So the 10 is the hypotenuse. Now, if it wasn't a right triangle, I'd have to find the height in there. All right, so type this in your calculator. 1/3 times 1/2 times 6 times 8 times 10. Type it in your calculator. 1/3 times 1/2 times 6 times 8. Oh, it's sticky. Times 10. Yes, something.
Yeah, so is mine. I spilled Pepsi on it.
Well, I didn't spill anything on mine. Volume is 80 what?
It still works though. Meters cubed.
80 meters cubed. Okay, so that is your front. If you look at all of these, they gave you the real height. So you don't have to do anything with slant height.
Can you go up here?
Now, flip it to the back.
All right.
On the back, we have some cones and we have spheres. Now, the volume of a cone is also 1/3 the base times height. But with the cone, we can get more specific. The area of the base is a circle. So it's 1/3 the area of the circle, pi r squared times h.
Wait,
So
which one are we using?
Well, this is the same formula, but instead of putting b here, I got more specific. It's the area of the base is a circle, which is pi r
So we're
squared.
not using the first one. All right.
You can,
No.
but this one's more detailed, so you don't have
That's the
to.
one you're gonna use that one.
All right, so it is 1/3 pi, and then what's the radius of this cone?
8.
I'm going to go with 8, half of 16, and then square it. Okay, now we want the answer with pi and then the decimal version. So the answer with pi, type in 1/3 8 squared. Oh, what's the height? We need to put that in there.
16.
16? Yep. All right, type that in your calculator, but don't type in the pi. So 1/3 times 8 squared
Wait, what are we
times
doing?
16. What do you mean on the end? And I get 341 1/3. So 341 1/3, yep, and don't forget your pi, and what will we label it? Feet cubed. Okay, so what is the decimal? I'm just going to hit times pi, because my calculator kept that answer, and I get 1072.3, nearest tenth.
Come on, Mike, we're already on that one.
Aliens. Okay, fabulous. I have another cone here. They gave me the height. Again, I don't want the slant height. I need the height, so they weren't making it hard. All right, now we have spheres. The volume of a sphere is on your formula sheet, and that is 4/3 pi r, and make sure you have it to the power of 3. Pi r squared is the area of a circle. It's 4/3 pi r to the third. surface area is 4 pi r squared. So be careful with that.
Wait, so which one are we using?
We're using this one, but they're very similar. That's why I want you guys to reference your formula sheets.
I don't even have one.
Well, you do. All right. So it's 4/3 pi. What's the radius of this one? 3 cubed. All right. So to type it in with pi in your answer, type in 4/3 times 3 to the third. I got 36. So what would I write? Yes. Kilometers cubed. And then take your 36 times pi and nearest tenth. 113.1 kilometers cubed. All right, make sure you're using the radius, not the diameter.
Can you do another one of those?
No, I'm good.
Come on.